Hello, this is Bruce Bender, Director of Public Works. Today we're presenting a presentation about the Rattlesnake Valley Sanitary Sewer Project, which is creating an SID 528. This is about a 3/4 of an hour presentation. First portion of it will be about the Rattlesnake Valley water quality issues, and this will be presented by Jim Carlson of the City County Health Department, and he's the Environmental Health Director. Second portion of the presentation is about the status of the wastewater facilities, and this will be presented by Bruce Bender, City Public Works Director. And the third portion will be about the SID 528 project itself for creating the sewer extension, and this will be presented by Steve King, City Engineer. So our first presentation will be Jim Carlson.
My name is Jim Carlson. I'm Director of the Environmental Health Division of the City County Health Department. There's two major reasons that we want the Rattlesnake sewer projects to go forward. The first one is aquifer protection. The aquifer in Missoula is our designated sole source drinking water supply. All of the drinking water in the Missoula urban area comes from the Missoula aquifer. It's an unconfined aquifer, and the disposal structure that we use for getting rid of septic waste and runoff off of the streets is the same structure that our water supply flows through and is pumped from. There's about 150 feet of sand and gravel. For the most part, there's no intervening layers of rock or very tight clays between the surface and that portion of the aquifer that we withdraw our water from. So whatever goes in on the surface or into the surface has the potential of contaminating our drinking water. We've had contamination problems in the past, and we currently have contamination problems, both chemical and biological. Protecting in an aquifer is much less expensive than treating water or cleaning up those contaminants. So the best way that the City County Health Department can perform its role, and that role is to ensure that the use of the aquifer is sustainable into the future, is to ensure that we do everything we can to protect it, because it's so much easier and so much less expensive to maintain the aquifer in a clean condition than it is to try to clean it up later. Another major reason we want this project and other projects in the Missoula area to go forward is for the purpose of surface water protection. Aquatic plants are threatening the ecology of the Clark Fork River. That plant life is caused by nutrients, primarily nitrates and phosphates, which are present in significant levels in sewage and human waste. Major sources of those nutrients are sewage from septic systems and treatment plants, and that's a major source not just in the Missoula area, but throughout the Clark Fork Basin. The VNRP, which stands for Voluntary Nutrient Reduction Plan, was established to manage nutrients in the Clark Fork drainage from Butte all the way down to its confluence with the Flathead River. These are two photographs taken of the Upper Clark Fork near Garrison and the Lower Clark Fork at Huson. Both photographs show significant amounts of algae growing in the river, and in fact the Garrison photo essentially shows algae that is growing 2 to 3 feet long from bank to bank in the Clark Fork River. Once we get down to The Missoula area, where the Bitterroot and the Clark Fork join together, the species of algae changes from the long filamentous cladophora to a shorter diatomaceous algae due to the widening and depthening of the river. But nonetheless, the problem is present from the headwaters of the Clark Fork all the way down to its confluence with the Flathead, where the Flathead is bringing in enough clean, low-nutrient water that the algae is no longer a problem. One does not have to be an expert in fisheries or aquatic biology to understand that a Rocky Mountain trout stream should not have plant growth of this nature throughout its length. It's unhealthy for the ecological system, it's unhealthy for the fish, at least the native fish, and it's something that needs to be corrected. So what are the impacts of septic systems in the rattlesnake? To understand that, we need to understand the different types of septic systems that are present. Certainly in those homes that were built before 1967, when sewer systems were not regulated, we have a number of cesspools. A cesspool is simply a buried tank or vault in the ground with holes in the sides and the bottom. So it provides a volume for the sewage to go outside the house, and the sewage decomposes somewhat in the septic cesspool and seeps out into the soils and eventually down into the groundwater, or another name for the groundwater in this case would be the Rattlesnake aquifer. Cesspools are anaerobic, meaning that there is not any oxygen present for the breakdown or treatment of the sewage. A seepage pit is essentially a cesspool with a septic tank placed in between the home and the absorption area, which we would now call a set of rings. The septic tank provides 24 to 48 hours of retention. This gives a little bit of time for some of the bacteria and viruses to die off. It also, main function is to remove 75 to 90% of the fats and sludge that come out of the home, which extends the life of the absorption system. So the septic tank was originally designed to try to collect a lot of the solids and fats so that the soil in the absorption area or seepage pit wouldn't become plugged with those materials quite as quickly. Seepage pits are also anaerobic, meaning there's no oxygen for the breakdown of the materials that come into them. And finally, we have drain fields, which have been required for new homes since the early 70s in Missoula County. A drain field is a septic tank, and then an absorption area that, rather than being buried and essentially surrounded in concrete, it's perforated pipe that's buried shallow within a few feet of the surface of the soil. And what that allows for is for aerobic treatment. Oxygen permeates the soil down to several feet, and this provides then for anaerobic treatment in the tank and aerobic treatment out in the field. It gives better breakdown. You get an entirely different set of bacteria breaking down sewage, so it works much better in terms of getting a total reduction. Still, all of the dissolved components coming out of a drain field go into the groundwater. Nearly 100% of the nitrogen gets oxidized to nitrate, and then it stays dissolved in the groundwater until eventually it either reaches a stream or a river. There's still significant discharges of gut bacteria and virus from a drain field. If that material is discharged relatively close to the surface of the groundwater and gets down into the groundwater and is not filtered out, then it can travel some significant distance, and in some cases can travel to someone else as well and cause disease in that household. So where does the septic effluent go in the Rattlesnake? Well, it all ends up in the Rattlesnake aquifer. The aquifer pretty much covers the entire populated valley in the Rattlesnake, meaning that there is a groundwater table underneath almost all of the homes. The exception to that may be the homes up on the hillside, of which there are relatively few. Nonetheless, effluent even from the hillsides percolates down, hits bedrock, and ends up in the Rattlesnake aquifer. Some of it then enters the Rattlesnake Creek. However, most of it exits the Rattlesnake Valley, flowing out through the aquifer. There's much more water leaving the Rattlesnake Valley in the aquifer than there is from the creek. It all eventually ends up in the Clark Fork River. The Clark Fork River loses water into the aquifer from the Bonner Dam all the way down to about Reserve Street. And then water from the aquifer is flowing back into the Clark Fork and Bitterroot below Reserve Street all the way out west to Huson, where there's contact with the bedrock, and all of the water from the Missoula aquifer eventually upwells into the Clark Fork by the time it reaches Huson. With regard to the creek itself, this is a graph showing the levels of nutrients during the fall of 2002 in the Spring Gulch area, just above where there's any human habitation in the Rattlesnake Valley. It increases as you get down to Pineview Park at the Rattlesnake Middle School. At that point then, the phosphorus levels off and the nitrogen keeps on increasing all the way down to Greeno Park at City Drive and the mouth of the Rattlesnake at the Clark Fork. The reason that we believe the phosphorus drops off is that as you get into the lower portions of the Rattlesnake Valley, you start to have significant amounts of clay present in the soil, whereas in the upper portions of the Rattlesnake Valley, the subsurface soils are made up largely of sands and gravels. Clay attenuates phosphorus temporarily, and as phosphorus flows through those clay particles, it's held up by the clay. Over time, the clay gets overwhelmed and eventually quits absorbing phosphorus. And the point I'm trying to make here is that all of the nitrogen either enters the aquifer or the creek, and a portion of the phosphorus enters, and over time, if we were to never sewer the Rattlesnake Valley, the phosphorus eventually would overwhelm the ability of the clay to absorb it, and would also, we would see dramatic increases in the impact from the clay. Impact from the phosphorus. There are about 876 septic systems in the entire Rattlesnake. This project is looking at sewering about 500 of those septic systems. They generate about 37 kilograms per day or 82 pounds per day of nitrate and 7 kilograms or 15 pounds per day of phosphorus. So if you're looking at the amount of nitrate that's contributed, that's about 400 pounds per day of 20% nitrogen lawn fertilizer. So the normal fertilizer you might buy for your lawn, we're generating about 400 pounds per day out of septic systems and into the groundwater 365 days a year. That amount of fertilizer has a significant impact on the aquatic systems of the Rattlesnake Creek and the Clark Fork. In fact, it's enough to contaminate about 33 million gallons a day to the nitrate standard of 300 parts per billion for surface waters. Someone had asked me to compare that then with the flows in Rattlesnake Creek during July, August, and September, which is the period when we have trouble with this algae growing. Rattlesnake Creek averages about 36 million gallons per day. So the amount of nitrate generated is enough to take the creek itself, if it all went into the creek, to about 91% of the standard. During the driest month of the year in terms of water flow in the creek, that occurs in August. Average flows are about 12 million gallons per day, and there's enough nitrogen going into the system from septic systems in the Rattlesnake at that point in time to be about 2.5 times over the standard. So if the Rattlesnake Creek was a unit unto itself, just the septic systems that are there now, I'm not talking about the other homes and the lawns, is enough to contaminate the creek itself to about 2.5 times the allowable standard. The new treatment plant will minimally remove 60% of the nitrate and 50% of the phosphorus, and that'll be done on a year-round basis. So your sewage, as it's entering, otherwise would enter the aquifer, enters at various times of the year, and then we have very little control of it, and it gets back into the river at various times of the year. The treatment plant ensures removal of these materials throughout the year. Permitted septic systems in the Rattlesnake. As I said, there's about 876 of them, and about 43% are drain fields and 57% are seepage pits. So as you can see, more than half of these systems are considered to be antiquated in that they don't have drain fields and they don't provide any aerobic treatment before the effluent is discharged into the groundwater. This is a map of the seepage pits and drain fields in the Rattlesnake. On this line right about here, you'd have the Lolo Street crossing. Van Buren here. Rattlesnake School is the black dot here in the middle. This would be the Sunflower area here and the east side of the Lincolnwood area, which is the unsewered area in Lincolnwood. Drain fields are shown in green. Seepage pits are shown in red. As you can see, fairly even numbers of drain fields and seepage pits in the middle Rattlesnake area. Over on the west side, we've got quite a few seepage pits. And then again up in the Lincolnwood area, lots and lots of seepage pits. The lots in these older areas of town, for the most part, like in the west side and in Lincolnwood, are not large enough to support a drain field. We couldn't find room in them, and in fact, on the west side of the Rattlesnake, many of these systems have been replaced so many times that there's hardly room for a septic system at all on these lots. In terms of looking at new and replacement systems, since 1967, and we started issuing permits, a number of the systems in the Rattlesnake have been replaced. That's about 35% of the 876 systems. And as you might expect, most of the replaced systems are located in the lower part of the Rattlesnake. I don't know if you recall earlier I said the soils tend to be tighter in the lower Rattlesnake. There's more clay there. That's perhaps a little better for treatment, but in terms of sewage backing up into your house, because the soils have become plugged with the sludge and dead bodies of the bacteria that are being discharged from the home, then most of that has occurred in the lower Rattlesnake. And in fact, in the area that's west of Duncan Drive, many of those systems have been replaced 2 and 3 times because of the tight soils and the fact that those systems are more susceptible to failure. Many of these homes then, next 10, 20 years, may be very difficult for them to find a place to get rid of the effluent from their parcel. On the other hand, you haven't seen many failures up in the northern part of the Rattlesnake. That's largely due to the very coarse soils up there. In fact, from a water quality standpoint, that's worse because the soils are so coarse they don't hold the sewage up long enough for it to be treated by the predatory bacteria that break down the bacteria that are discharged from the homes. The community has an obligation to connect 3,500 of 7,000 valley septic systems to public sewer by the year 2008. That obligation is created by the VNRP, and it's there in order to reduce nutrient loading on the river. After 2008, we're required to maintain the number of septics in the Missoula Valley at not more than 3,500. Now, this is an agreement that the City Council, the County Commissioners, the City-County Board of Health, the State of Montana, Department of Environmental Quality, EPA, as well as Stone Container, the City of Butte, and the City of Deer Lodge have all signed on to. They all have different responsibilities, but in terms of the responsibility in Missoula, this is one of the big ones, to get a lot of these septic systems connected to our new wastewater treatment plant, which will remove significant percentages of these nutrients that otherwise would not get removed. So, in terms of homeowner reasons to have public sewer, we have to look at the fact that once you're connected to sewer, there's no homeowner maintenance of a tank, and the treatment and disposal costs of sewage are no longer your problem. It provides for a solution to disposal problem on small lots with tight soils. There are a number of lots in the Rattlesnake that are not large enough to support a drain field, and in some situations the lots aren't large enough hardly to support the replacement of a seepage pit. Those people on the west side should be very interested in this project from the standpoint of not having continued failed systems, not having to tear up their lawns, and having some place to dispose of their sewage. There's no concern with failure at inconvenient times. Sometimes septic systems, fail when company's there and the system is at higher level of use than would otherwise be the case, or they fail in the middle of winter when the entire lawn has to be thawed so that an excavator can get in there and do some digging. There'll only be one more dig up of the lawn once you're connected. And finally, it's the best decision to make in terms of protecting our aquifer and remediating our surface waters back to acceptable standards. And our next presentation will be given by Bruce Bender.
This is Bruce Bender, Director of Public Works for the city. I want to talk about the wastewater facilities. This is important in regards to the Rattlesnake Valley Sewer Project because obviously we want to handle the wastewater that comes from the Rattlesnake, and so it's important for you to understand the quality and the status of our current facilities. So we're going to talk about the treatment portion that primarily centers around the treatment plant. And then obviously the collection system, that's how we obviously collect it from the Rattlesnake Valley and then transport it to the treatment plant. We're going to talk about the history and the current status of both of these areas, of treatment and collection. So historically, the treatment plant was, our first one was constructed in 1963, and it had a capacity of 5 million gallons per day. And since then, we've been upgrading that or improving it about every 10 years, roughly. First, we went to what we call secondary treatment, and it also got expanded. And then in 84, 85, we improved even the secondary treatment with an aeration system. Jim Carlson talked about the importance of putting oxygen in the system. This is part of the treatment plant's role. And then in 91, we also improved another portion of the plant, and then it got expanded finally to 9 million gallons per day, which is its current capacity. Now, also during this period of time, the city did, as Jim Carlson mentioned, enter into the VNRP, the Voluntary Nutrient Reduction Program. And this was adopted by the state, the city, county, and also other agencies along the river, and along with the Tri-State Council, which is a multi-state group. So what is the VNRP, the Voluntary Nutrient Reduction Program? Jim Carlson briefly talked about it. It obviously deals with nutrients and our commitment to reducing that to protect the river. The Clark Fork Voluntary Nutrient Reduction Plan has these goals. Goal of restoring beneficial use to the Clark Fork River by eliminating the algae growth. Sets specific targets to remove the nitrogen and phosphorus from the river. And it also quantifies these targets for the 4 key point sources and also the Missoula area groundwater septic load. And it recognizes the importance of the summer, the seasonality of how vulnerable the Clark Fork River is during the summer. So it obviously sets these limits, and these are an example of what is in the agreement. Butte, Deer Lodge, Missoula, Stone Container all have limitations on phosphorus and nitrogen. And along with that are non-point source reductions into the general Missoula area groundwater septic system, along with the Bitterroot and then the Clark Fork itself. So as I said, here's a specific that deals with the Missoula wastewater treatment plant. The reductions are to be 50% phosphorus reduction and 20% in the nitrogen. So in summary, for the Missoula area, you got the treatment plant at 50 and 20%, but also the Missoula area is to have a 40% reduction in its nitrogen contribution from the septic systems. And as Jim Carlson mentioned, that's very specific on numbers of the quantity of septic systems we have to reduce, which equates to about 50%, and then holding to that number. So what is the current status of our treatment plant itself? This particular slide speaks to how the current plant has operated for the last 10 years. The upper level that is there is the permit level. This basically is the blue and the yellow line that runs across there. That's the maximum level that we're permitted to discharge on these 2 type of limits. One is called a TSS, which is suspended solids, kind of like how dirty the water is. And then the BOD talks about the oxygen demand of it, or the type of sewage you're putting out. So again, these are permit limits, but then this is how the plant has operated for the last 10 years, is the jagged lines down below. And you can see, therefore, for the last 10 years, we've been substantially below our permit limits. And then this black line in the middle actually shows the volume of flow at the treatment plant. Initially, in the early 90s, we were more down about 6 million gallons, and we've grown to 8.4. And even with that growth, we've been continuing to maintain our treatment, treating the effluent to way below the treatment level. Now, currently, we are under an expansion that began in October and will continue. And this upgrade is obviously very significant for the meeting our VNRP, for reducing our nutrients, because basically this treatment plant upgrade of almost $19 million is implementing a new type of process called biological nutrient removal. And this will reduce our nitrogen by 50% and our phosphorus by 50%. And these are at full capacity, so initially it'll even do better. And along with this, introducing this nutrient removal, we're also going to be expanding the plant by 30%. So the increased capacity, we're currently right now treating about 8.2 million gallons per day, and we'll increase our capacity by 50%. So let's talk about the collection of our system and history and both the current status. Historically, when you look at the collection system, Missoula has been using the Clark Fork River as a waste disposal system. We basically collected our waste both from pipes or from septic systems and have been dumping it into our river. So the origin of this begins back in 1910, where the first collection systems were built, but what's significant is that it was discharging directly into the river. So obviously it was the downtown area here and also the lower Rattlesnake in those first few years. These green represents the locations of the connections. And then what got connected between the 20s and 30s is in this light green, and that was kind of south of the river. So again, a new collection system was installed at that period of time, and it also discharged directly into the river. And then there's some additions of that in the 40s on the west side. And then the 50s, it kept expanding. Now, basically, at this point, we're again discharging raw water, sewage water into the Clark Fork River. But at that time, in 1961, wastewater treatment plant planning study showed that only 40% of the existing homes and businesses were connected to this collector system I was just showing you. So basically, 60% were using cesspools. And so if you take this area now, double it basically, and then you can see how much also was on septic system, because this is the portion that was on the collection system. But in the 60s, with the treatment plant getting built, then the collection system did expand quite a bit to the south and university, south of the university area, to the west primarily. And then also, even in the upper Rattlesnake area, there was a small area there that was added on also in the treatment plant. So this sewage now is being treated, and the treatment plant was in operation. Now, the 70s, you start seeing the expansion occur in the South Hills. This was all done by a developer. And then the existing housing in the Farviews area started to get connected, and you see some areas on the west, and then some areas on the northwest. 81, 84, we did adopt the new wastewater facilities plan, and Rattlesnake Valley was included in that area. 88, the aquifer became designated sole source aquifer, as Jim Carlson had described to you. So in the 80s, then you can see again more expansion of the system. What's significant for the Rattlesnake, Lincoln Hills came on that system. Also Ben Hughes on the east of Missoula. And then some portions around in the south, and then the airport and Grant Creek were added. Also in 92, then the Water Quality District was created to protect our drinking water. And then in 95 to 2000, a facilities plan was created that was developed and updated. And in 96, the Water Quality District did an evaluation of unsewered areas, and then it ranked the Rattlesnake Valley as being the number 5 priority or importance of getting connected based upon the amount of septic system and discharge of wastewater was putting into the ground. So the 99s now show primarily that what got expanded was the Linda Vista area, Wapakea, Bellevue area, all in the Cold Springs area. Those were all major expansions, and then some scattered along East Reserve and up here in the Reserve Street area, some more portions of Grant Creek, and then we had some expansions in the Rattlesnake. And so you can see here in the green that in the last couple of years have been just filling in those particular areas. And this is where we stand today. So what is the status or the quality of our current collection system? First standard would be look at how much water infiltrates into our system, in other words, groundwater. And basically, we are below the national standards, so it speaks to the integrity of our system, that we do not receive a large amount of inflow of our water versus the national standard. Also, the average flow that we receive per capita connected is average, so again talks to the integrity or the quality of our pipe system. Now this year we did extensive amount of about 8 miles of our oldest pipe was TV inspected, and as a result of that inspection we did find about 60 feet at various locations needs to be repaired. So this represents basically 0.15% that would need to be repaired. So maintenance of our system. We hydroclean our sewer system all 240 miles every 2 years. Hydrocleaning means that's like a big jet hose that truck shows that's run through the lines. This gives us an opportunity not only to clean it but also to verify the connection of it. And as a result of this hydrocleaning, we do a various amount of repair work throughout our system. And over the last 8 years, we've done 1 mile of pipe replaced at 150 locations. And then we've had some also significant projects with large diameter pipe, which carries the most flow. And then we've been have replaced about 8 miles in the last 10 years. So what are some frequently asked questions in regards to this planning in our system, wastewater system? Does the wastewater system comply with state and federal environmental review requirements, or NEPA, MEPA? Yes, both the 84 and 99 plans did complete environmental reviews in accordance with federal and state regulations. Both plans were approved by the state and EPA officials, and the Rattlesnake Valley project was included in both of these plans. How about the capacity of the treatment plant? I heard the treatment plant has reached or exceeded this capacity, and as I mentioned, we have 9 million gallons capacity, and we currently treat about 8.2. But we're also expanding and are undergoing improvements that will expand it to 12, and then also improving the treatment that will enable us to remove nutrients. And these improvements will be completed in about 2 years. So Steve King will now speak about the SID project, so that concludes my presentation.
Okay. My name is Steve King. I'm the Missoula City Engineer. I'm here to speak about the actual SID creation and construction with the Rattlesnake Sewer project. As Mr. Bender talked about, there's 40 years of history of public sewer in the Rattlesnake. Currently, there's over 1,100 properties connected to the sewer in the Rattlesnake Valley, and the connections began in the early 60s when the wastewater treatment plant was installed. This Special Improvement District 528 would expand the sewer to the remaining 570 properties inside the city limits in the Rattlesnake Valley. And there is also progression in the Rattlesnake Valley of the sewer connections. You can see the connections in the lower valley in the 1960s and 70s. And significantly in 1980s, the county created a rural special improvement district to bring the sewers up the Rattlesnake Valley to relieve the failing septic systems in the Lincoln Hills and Lincoln Wood neighborhoods. In the 1990s, subdivision continued, and continuing septic system failures caused several additional special improvement districts in the Rattlesnake Valley. And up to the present, a vast portion of the Rattlesnake Valley, those 1,100 systems, are shown in this picture. The Special Improvement District would complete the system in the Rattlesnake Valley. Project funding in the city has fulfilled a commitment to bring a substantial subsidy to the project. Half the cost of the sewer mains will be funded by combinations of grants and SID and sewer dollars, city sewer dollars. The remaining would be funded by the Special Improvement District. There's several different types of grants. Again, half the cost of the sewer mains totals about $2.5 million. The average sewer main grant for each of the 570 properties in the Special Improvement District is over $4,300 per property. That's a subsidy built in to the project at this point. There is additional grant funds available for sewer connection assistance, and I'll go into that as well. So how's this project funded? The total project cost is about $6.6 million. The Special Improvement District's proposed to share about $4.1 million of that total cost, and the balance would be made up by state, federal, and local grants. It's the $2.5 million that I mentioned previously. There is additional cost for connecting the house beyond these project funds. Total project funding, it's made up of a variety of funding sources, both the Special Improvement District for mains, SID for stubs. There's other grant funds that I'll get into in the city funds. But significantly, about 62% of the projects proposed to be funded by SID and 38% funded by state and local grants. So what are those grant monies? The city sewer fund is almost $1.9 million. The Treasure State Endowment is $500,000. That's the coal tax trust fund, and a distribution on the state level from our coal tax funds is Treasure State Endowment. Additionally, the city is seeking to be granted $100,000 from the Montana Department of Natural Resources and Conservation. Also, for connection assistance, the Missoula Valley Water Quality District's bringing $225,000 to the project, and there's additional funds for low-income and owner-occupied homes. Grant funds to cover the cost for low income. As I mentioned, low-income owner-occupied properties may qualify for connection cost assistance. The City Program Income Funds is a federally sponsored program for homeowners with household incomes under 80% of the median household income. As I mentioned, there's also grant funds to defray connection costs for everybody in the Rattlesnake Valley. The Missoula Valley Water Quality District has committed $225,000 for connection assistance, grants for individual property owners that connect to the new sewer within 2 years, and the minimum connection grant is $375 per property. So the Rattlesnake is a diverse area, and we've split the area into 4 neighborhoods. Average SID costs are based on the sub-districts in the Rattlesnake Valley. And SID estimates include both a sewer main and 1 service stub per property. So the SID cost has 2 basic parts, one for the sewer main and one for the sewer stub. Not all properties have the sewer stubs, but if they do have a sewer stub, it's included into the cost estimates. Those sewer stubs cost $1,800 each. So the average cost ranges for the 570 properties in the Rattlesnake Valley. 92 of the 570 properties have assessments of less than $5,000. 333 properties have assessments between $5,000 and $7,000, and 145 properties have assessments over $7,000. All cost includes the service stubs. SID assessment method. The state of Montana specifies SID assessment methods, and the City Council adopts one of the state-specified assessment methods. On this project, the SID is proposed to be funded for the sewer mains based on the area and value of each property. Half of the sewer main assessment cost is based on the actual area, physical area of the property, and the other half of the sewer main assessment is based on the value of the bare land. It's the unimproved bare land as recorded by the county assessor's office for the value of the bare land of the property. The SID service stub assessments is a lump sum cost per stub, and that's the $1,800. There is assessment reductions for various unique situations. The area calculations for larger parcels have been reduced by areas in the hillside, steeper than 25%, or it's considered unbuildable, and that area is not counted. There's also areas in the floodplain or a designated flood hazard area are reduced from assessments for larger parcels. The assessments, the SID assessments by size and value, by sub-district, are as follows. There's 4 sub-districts. The Lincolnwood area has 118 properties. The median cost or average cost is $5,778. That translates over 20 years of assessment to $445 per year or $37 a month. Likewise, the various sub-districts have various costs depending on the particularities of those sub-districts. Upper Rattlesnake is about $6,600. Lincoln School Neighborhood is about $5,600, and the Duncan Drive area is also about $5,700. But that's not the total cost, it's just the SID. We've taken a typical sub-district, the Lincolnwood area, with its SID principal of $5,778 on average. As it said, it translates with interest, 4.5% interest, a federally subsidized interest rate. For 20 years, that's $445. Interest charge is charged on the SID principal when the bonds are issued to finance the project. So a typical on-site connection cost beyond the SID cost, excavation contractor would charge estimated $3,500 for the actual connection into the house plumbing. There's $922 of city fees. So the total connection cost is the SID plus the connection plus the fees. Again, a typical average total cost for connection, approximately $10,200. The SID process. On January 13th, and these are schedules that are estimated at this point and could change, but we're planning on January 13th. Council would consider the resolution of intention to create the district. On January 17th, certified letters with notices of the SID are mailed to all the property owners in the district. January 19th, a legal notice would be published in the Missoulian. January 20th is the beginning of the formal comment period for the project. And at February 3rd, the completion of the comment period, there would be a public hearing before the Missoula City Council to consider creation of the district. If the council creates the district, we would begin construction, bid the project in spring of 2003, start construction in 2003, and because it's a large project, take us more than a year to complete. It would be completed in the summer of 2004. The first SID bills would come out if we did get a rapid completion of the project. We could bill as soon as the fall of 2003. Much more likely is that the first SID bills would be in the fall of 2004. Letters will be sent to property owners with contractor information to let them know that the system's available for connection, and the lines will be available for house connections as they're completed over the term of the project. Once again, the SID is billed over 20 years at 4.5% interest. Some frequently asked questions regarding the project. As the city looked at alternatives to the gravity sewer system that's proposed. And yes, the city has evaluated several viable alternatives, including step system, vacuum system, and other systems, but the conventional gravity sewer system is the most economical and maintainable of all the systems we looked at. Development density. Will the SID sewer extensions cause increased dense development or infill in the Rattlesnake Valley on existing lots? Well, the truth is the public sewer is already currently available with reasonable extensions to most of the vacant properties in the vicinity of SID 528. Also, public sewer is currently available to over 1,100 properties in the Rattlesnake Valley. The SID will primarily enable existing houses to connect to the public sewer. Should we SID now or later? Why is one large project being considered now instead of a series of smaller projects over time as septic systems fail? Well, it's more economical to do one large project versus a series of smaller projects. Grant funds are currently available for large projects. And the Voluntary Nutrient Reduction Program and state and local laws commits the community to extensions of sewer system in the Rattlesnake Valley. How can a city support or protest creation of the SID? Can a protest be rescinded after it has been signed? The formal comment period for property owners starts after legal notice of the passage of the resolution of intention to create the SID. The SID protests may be submitted or rescinded during the 15-day following the legal notice up to 5 p.m. the date of the public hearing, and that public hearing is currently scheduled for February 3rd. How can I get more information about this project? Well, there's several sources. The Missoula County website, it's www.co.missoula.mt.us/water quality/FAQ for frequently asked questions, has links to the VNRP, and the unsewered area studies. Also, the City Public Works Department and the Missoula County Library have copies of the wastewater facilities plan for the community. So that's how you can get more information. That concludes our presentation on this project. Thank you.